A bouncing ball always rebounds to square root of 3 over 2 plus square root of 3 of the height from which it is dropped. When dropped from a height of 4 minus 2 square root of 3, determine the total distance it travels as it undergoes infinitely many bounces. So you see the word infinite, so it's going to be some sort of an infinite series. Okay, and since it is going to be based off a fraction, it's rebounding to a fraction of the height, it's going to be a geometric series. So it's an infinite geometric series, and therefore I'm going to be using the formula for an infinite geometric series, where the formula is S, or the sum, equals term 1 over 1 minus r. Okay, so this right here is your formula. So it's going to help if I draw a picture to fully understand what is happening. So over here you see a picture where I'm starting at 4 minus 2 square root of 3. It's going to come down, hit the ground, bounce back up, go back down. It's going to keep decreasing in height each time. So T1 is where it's starting. So T1 is going to be the height of 4 minus 2 square root of 3. So you see that right here, 4 minus 2 square root of 3. Okay, and then your common ratio is the fraction of which the height that it's keeping. So the square root of 3 over 2 plus square root of 3, that is your common ratio. Okay, so in your formula, T1 is 4 minus 2 square root of 3, then you have 1 minus square root of 3 over 2 plus square root of 3. So that's what you have right here. Now the question is, where does the other stuff come from? Why do we have a 2 and why are we subtracting something? So the reason is, if you take a look at the picture, you notice that when it hits the ground right here, okay, it's going to bounce up and it's going to reach this height and then it's going to come back down. Okay, so what we're finding if I just do it one time, use this formula for one time, it's only going to show just one direction of travel. Okay, so I need to multiply by 2 to account for the up motion and then once again for the down motion. So multiplying by 2 to account for that. And then we're subtracting 4 minus 2 square root of 3 because if I just have this part right over here and not subtract anything, we are assuming that with the picture that it starts on the ground at the bottom and it's going to come back up and travel twice up to 4 minus 2 square root of 3. But you notice here we only have half of a arc, or whatever you want to call it, half a parabola right here for my first initial drop. So I need to subtract out the other half that this formula is giving me. So I'm subtracting the 4 minus 2 square root of 3 to account for that. So when I go through all the math, I'm not going to take the time to do all of that. I hope you know at this point how to do that. But your final answer is going to be 2 square root of 3 minus 2.